Hi all, I am T. Shakti Shri, Assistant Professor of Department of Information Technology, Hindustan College of Engineering and Technology. In this video, we are going to learn the basics of tree data structure. In this video, we are going to learn the definition of tree data structure, followed by the basic terminologies that are being used in tree data structure, binary tree, and the types of binary tree. Let us get into the definition of tree data structure. A tree is a non-linear data structure which presents hierarchical relationship between data items. A tree is also defined as a set of one or more nodes with one designated node called root, and all other nodes can be portioned into non-empty sets, each of which is a subtree of root node. A tree is going to be a collection of nodes, one of which is the root, and it will be having, if you're having n number of nodes, then there will be n minus 1 edges. Follows from the fact that each edge connects to the parent node, and every node except the root has one parent. Let us see the structure of a tree here. As we have already seen, the structure of this tree starts with a special designated node called root. Followed by that, we can have any number of child nodes. In a general tree, we don't have any restriction on the number of child nodes. So the given example is going to be an example of a generic tree where we have roots followed by the parents, and there will be siblings, parents, children nodes, subtree, leaf nodes. These are all the various terminologies that are going to be a part of a structure of a tree. Getting into the properties of a tree can contain n nodes, or it can contain one special node called root with 0 or more subtrees. Each edge of the tree is directly or indirectly originated from the parent, that is originated from the root. Every child has one parent, but one parent can have many children. Getting into the basic terminologies of tree. The first term is root. The first node from where the tree begins or originates is called as the root node. In any tree, there must be only one root node. Next is edge. The connecting link between any two nodes is called an edge. In a tree with n number of nodes, there will be n minus 1 number of edges. Here, in the example given, node A is the root, and the link which connects A with B and with other child nodes is termed as an edge. Parent. The node which has a branch from it to any other node is called a parent node. In other words, we can say like the node which has one or more children is called as a parent node. In a tree, a parent node can have any number of child nodes. In the example, except I, J, K, F and H, all other nodes can be termed as a parent node. The next term is child. The node which is a descendant of some node is called as a child node. All the nodes except root node are called child nodes because root is the originating node. So the root node cannot be termed as a child node. It is the parent node. Siblings. Nodes which belong to the same parent are called as siblings. In other words, we can put it as nodes with the same parent or sibling nodes. In the given example, the nodes D, E, F are siblings, as well B and C are sibling. The next term we are going to see about is degree of a node. The degree of a node is the total number of children of that particular node. For example, for the node B, the degree is going to be D, E and F. And then degree of a tree, that is the highest degree of a node among all the other nodes, is termed as the degree of a complete tree. For example, degree of a node C, it has 2 children. So the degree of a node C is termed as 2. Internal node. The node which has at least one child is called as an internal node. Internal nodes are also called as non-terminal nodes. All parent node can be termed as an internal node. Getting to the definition of leaf node, the node which does not have any child is called as a leaf node. Leaf nodes are also called as external nodes or terminal nodes. The next definition is level. In a tree, each step from top to bottom is called as level of a tree. The parent node starts at level 0 and it goes on till the child node. The child node will be at the lowest level. Height. The total number of edges that lies on the longest path from any leaf node to a particular node is called as the height of that node. Height of a tree is called as the height of root node. Height of all leaf nodes will be 0. All leaf nodes will be at the height of 0, and height of node A. A is the parent node. The longest path is going to be 3. So the height of node A is 3. Getting into the height of node B, the longest path for node B is 2. And similarly, the longest path for height C is 2. So the height of node B and node C are termed as 2. The next term is depth. Total number of edges from root node to a particular node is called as depth of that node. The depth of the tree is the total number of edges from root node to the leaf node in the longest path. Depth of root node is equal to 0. The terms level and depth can be used interchangeably. Next, we are going to see the implementation of general tree. As we know that in general tree, every parent node can have any number of children. We don't have any restriction. So the way to represent a general tree is, on the left hand side we are going to have the first child, and on the right hand side we are going to have the siblings. This is the common representation for a general tree, which is termed as left child right sibling data structure for general tree. So in this example, the parent node A has been represented. As it is a parent node, it doesn't have any siblings, so it has been marked as null in the right child. Getting to the second level, we have two children B and C. So left child has been marked as B for A, and B does not have any children, so its left child is marked as 0. On the right hand side, as it has a sibling C, it has been marked with the address of C. C does not have any siblings further, so the sibling that is left right hand side has been marked as null, and it has a child, so left has been marked with the child node D. As D doesn't have any child as well as sibling, both the left child and right sibling is marked as null. Getting to the definition of binary tree. Till now we have seen just about the binary tree, but we have a problem with the binary tree because we don't have an efficient implementation of a binary tree, and we are going to move on with a very effective tree representation called binary tree. A binary tree is a tree in which no node can have more than 2 children, and these children are described as left child and right child of the parent node. The maximum number of nodes at level I of a binary tree is 2 to the power I plus 1 minus 1. For example, if we have 3 levels, then the maximum number of nodes we can have here will be going to be 8. 2 to the power I plus 1, which is the level will be 0, 1 and 2. So 2 plus 1, it becomes 3. So 2 to the power 3, it is going to be 8 and then minus 1. So sorry, totally it is going to be 7 nodes over here. Properties of binary tree. At each level of I, the maximum number of nodes is 2 to the power I. If the number of nodes is minimum, then the height of the tree would be maximum. Conversely, if the number of nodes is maximum, then the height of the tree would be minimum. Because if all the levels are being filled, automatically the height of the tree will be reduced. Next, we are going to see the various types of binary trees that can be represented. Getting to the first type of binary tree is rooted binary tree. The example diagrams are about rooted binary tree. It is a tree in which every node can have at most 2 children. All these things are going to be an example of a rooted binary tree. Second one is full binary tree or proper binary tree. In this, every node has 0 or 2 children. Unlike the first one where we have a right child, when getting into full binary tree or proper binary tree, every node should have left as well as the right child. Otherwise, it is going to be a leaf node. If it is a leaf node, then there won't be any children at all, right? So that is what is called as a full binary tree or proper binary tree. Next type of binary tree is perfect binary tree. By the name we can understand that it is a full binary tree in which all leaves are at the same level. But when we get into the example of a full binary tree, we'll be having leaf nodes at any levels. We don't have any restriction when we draw a full binary tree. But when we get into perfect binary tree, all the leaf nodes should be at the same length, which means that all the levels has to be filled. getting into the next type of tree, which is complete binary tree. It is an example of it can be termed as a full binary tree in which all leaf are at depth n or n minus 1, not more than n minus 1. We'll be able to see the difference between perfect binary tree and complete binary tree with the example over here. So here we have leaf nodes, that is in complete binary tree we have leaf nodes at n as well as n minus 1, but in perfect binary tree we have leaf nodes at the level n. The next type of binary tree is almost complete binary tree. It is a tree in which each node that has a right child also has a left child. Having a left child does not require a node to have a right child, which means that we cannot have a node simply with a right child, but we can have a node with the left child alone. That is what is termed as almost complete binary tree. Getting to the last type of binary tree is left and right skewed tree. There is a possibility that we will be having only left subtrees and right subtrees. If it has been if we have nodes only in the left side, then it is called as left skewed tree, and if we have nodes only in the right child, then it is termed as right skewed tree. I hope in this video you might have got a better understanding about what a tree data structure is and what are all the basic terminologies that are being used in tree data structure, followed by the representation of a general tree and then the various types of binary trees that are available. Thank you.